Hi, I'm Carl Franklin. In this episode of Blazor Train, I'm introducing AVN Audio, a component I wrote to process audio data from a microphone or other audio source and supply buffers with an event in real time as they are recorded. Here's a link to the public repo. The solution includes demos. In a standalone WebAssembly app, I'll record a WebM file, more on that later, and save it to the Downloads folder. In a hosted WASM app, I'll send buffers up to a SignalR hub, which can convert them into raw PCM data using FFmpeg. Not only that, but I've written a processor that will convert those buffers and write them to a PCM file on a secondary thread. And that's all coming up right now, right here on Blazor Train! This is my public GitHub repo for AVN Audio. So this is a Blazor component for recording audio in real time, and it gives audio buffers in real time. Now, I have a dependency on FFmpeg, which is an open source executable-based converter and all-around great media utility tool, because the goal of this demo is to be able to analyze data in real time. And to do analysis, we kind of have to convert it to raw PCM audio. Now, after poking around, it appears that most browsers no longer support recording raw wave data. Instead, they're using Google's new Audio WebM format, relatively new. So WebM is an alternative to H.264 for video, and for audio, it uses either Opus or Vorbis, Ogg Vorbis. It's highly compressed, good for data transfer, and the quality is decent. So remember, we can't just record raw PCM data in the browser anymore. At least, I don't know how to do that. Maybe it's possible, but by default, WebM with Vorbis is what Chromium supports anyway, which is the most popular browser engine. Both Chrome and Edge use Chromium. So I've got a few demos here. And in one of the demos, I'm sending audio data buffers up to SignalR, and SignalR is going to decode each one of those into PCM audio. So before we can use this demo, I have to download FFmpeg. Here's Windows. I'm going to grab the latest Win64 and install it. Now, FFmpeg is only used by the demo that sends data to SignalR, and that's this one right here, AVN Audio SignalR Demo Server. And if you look at ffmpeg.txt right here, it says you have to download FFmpeg and copy the executable right there. And right off screen, I have it here. FFmpeg exe is now in my server project folder. All right, so getting back to the README, let's look at all the projects in the solution here. AVN Audio is a Razor class library you can use in Blazor to record audio. This doesn't use FFmpeg. It records WebM with the Vorbis codec. So in order to use it, you have to add AVN Audio interop to your project. But that's it. You don't have to link directly to any JavaScript files. This is the only requirement. All right, so the first demo I'll show you is a standalone WebAssembly demo. AVN Audio WASM demo. So this is going to record audio, save it to a local WebM file, and it uses a package called Blazor File Saver. And this is a cool package to easily save files in a Blazor WebAssembly application. It's really easy, and I'll show you how to use it. So the first thing you do is enumerate the input devices. You tell AVN Audio to give you a list of input devices and you pick one, okay? And then you can start recording. And it's going to record every buffer and save it to a WebM file, and it'll download it when you stop. Easy. Windows can play WebM files, Macs can play WebM files, everybody can right now. Next is the SignalR demo. So this is a hosted Blazor WebAssembly app that records and sends each buffer up to a SignalR hub. Now, there's two hub methods we can call. One is process audio file buffer, where the SignalR hub saves the data to a local WebM file. Once the whole file has been uploaded, the server calls out to FFmpeg to convert the WebM file to WAV and the sample type, and it does this at the same time. It changes the sample type from 48,000 to whatever the desired sample rate is. And then it deletes the original WebM file, right? So you can essentially end up with a WAV file. Now, the second one is more interesting, process audio buffer. So when you call this sending a buffer, it converts that buffer from WebM to PCM with FFmpeg on the fly. Now, it can do it two ways. You can just say, hey, convert this buffer, or you can use a background process, which will convert each buffer in a queue and write it to a PCM file as you upload. So before I get into the guts of AVN Audio, let me show you how to use it. So this is the AVN Audio WASM demo. It's a standalone WebAssembly application. And I've injected my Blazor file saver. And if we look at program, here's that Blazor file saver. And you also have to add AVN Audio Interop. And I'll talk about what that is in a minute. So here I'm defining my component, audio recorder, which is the component inside AVN Audio. I have a reference to it right here, audio recorder. I have three variables, sample rate, channels, and time slice. Those are just integers. Channels is going to be either 1 for mono or 2 for stereo. Sample rate is the number of samples per second. So here are some values, 6,000, 8,000, 11,025, 16,000, 22,050, 32,000, 44,1, which is CD quality, and 48, which is DVD quality, if anybody remembers what those are. And it's also what films use. The time slice is the number of milliseconds in between each buffer. So I have it set to 1 second. So every second, I'm going to get a callback that passes an audio buffer. Okay? So those three variables are right there. Then I have some events, buffer recorded, recording started, recording stopped. And here's a parameter, input devices, which is a list of browser media device, which is defined in AVN Audio also. And then I have a status changed event. So there isn't much code here. I'll go through it after we run it, but I'm just going to run it first, and then I'll show you how it works. All right, so the first thing I do is click Enumerate Devices. And if you're running it for the first time, you're going to get a pop-up dialog that says, hey, are you going to allow this website to access your camera and microphone? You say yes. Yes, I know I have a lot of devices. So I'm going to pick this one, which is my main mic that I'm using right now. And I'll say start recording. Now watch right here. I'll zoom in. Watch right here where it says audio devices found. All right, I'm recording. This is the total number of bytes that I've recorded. And every time I get a new buffer, it updates. And then I'm going to say stop recording. I've got a little WebM file ready for opening. I'll click open file. This is the total number of bytes that I've recorded. And every time I get a new buffer, it updates. All right, so you get it. And I know you couldn't see that player. It was off screen. But it basically came up in the media player. So that's really it. That's the first demo. All right, let's take a look at how it works. All right, you can see I've got my start recording button, my stop recording button, and I have that select for the list of devices. Let's look at the code here. First things first, browser media device. This defines each device. So if I press F12, we can go here. Now you notice that the properties are camel case because they come from JavaScript, and this is how JavaScript defines properties of an object in JSON, just like that. So without that, they won't match. Or you could do some tricks to make them match, but that's it. So I have a list of those called audio input devices, and that is my parameter for input devices. Basically, I'm going to let the component add devices to it. Now I've got some variables here, my status that I show right there. Record button disabled is a Boolean for enabling and disabling the record button. I have another one for the stop button. Now I have a string, selected input device ID. And this is the ID of the selected recording device. When I selected my device, that's what gets set. Then I have my WebM file name, which I'm going to set later. I have a stream, a WebM file stream for writing to that WebM file. And then I have bytes recorded that I keep track of. All right, down at the bottom, enumerate devices. The user has clicked the enumerate devices button, and this is the reference to the component, audio recorder. Just say enumerate devices. Then what happens is that list gets filled up, and this audio status changed event fires. So you don't have to do anything. It's just going to fill up. And then you can set the status to whatever that is, which will be, devices found. Okay. Now when I click on a device, input device selected happens, right? This is my on changed. So I set selected input device ID, and I enable the record button. When we push the record button, start recording happens. Initialize bytes recorded to 0. Now I'm creating a temp file, this temp WebM file. Here's the deal. I can't just write to a file on the desktop or in the documents folder or anywhere else because this is a WebAssembly application. But if I say my documents, it's going to use a temporary directory inside WebAssembly that I can write to. I can't share that with anybody. That's why I have the Blazor file saver component. So I'm going to write to this one, and then when I'm done with everything, we'll save the whole thing with that component. So first I get the stream, I open the file for writing, I tell the audio recorder component to start recording with the selected input device ID, enable and disable the buttons, and we're off to the races. Next, recording starts, and you get the recording started event. You can do something here if you want to. We don't need to in this demo. Then audio buffer recorded happens when a new buffer arrives, and it passes this audio buffer class. So that has a buffer string, which is a base 64 encoded version of the buffer, and it has a byte array data. Now, if I can write to the file stream at this point, I do. I take the data, which is the byte array, and I write it to the file. I increment the bytes recorded, and I update the status. Received this many bytes at this time. When the user clicks the stop button, we say, await audio recorder stop recording, enable and disable the buttons, and then recording stopped occurs. So here I set the status, I close the file, and now here's the thing. I'm reading all the bytes into an array. Not something you should do. This is just a demo. Then I'm calling Blazor File Saver to save the file to recorded.webm. And that's it. All right, let's talk about AVN audio itself. You saw browser media device. We have that. Let's talk about the JavaScript. I have functions that I'm exporting. This one is for stopping recording. This one is for starting recording. But I also have enumerate devices. And if you saw the episode of Blazor Train I did on components, I had this in there. So enumerate audio devices. This is all the gobbledygook JavaScript stuff that you need in order to return a list of available audio devices. And there's a couple of different ways that we're using it. Get user media is the first thing I try, but it doesn't always work. And if that doesn't work, I try media devices, enumerate devices. Either way, at some point, we're going to invoke a C# method, available audio devices, passing that list of devices. All right, now let's look at start recording. So I pass .NET object, which is an object reference to my component, the device ID, the sample rate, the channels, the time slice. This constraints right here is passed to get user media, and I pass the device ID and the channel count right here, those constraints. And then the options here, MIME type audio WebM, which is the default, and the bits per second, that's actually passed when I create a media recorder. So first of all, I have to get the user media, which gets the actual device, and then I get a stream, and I use that stream with the options to create a media recorder. Now we have a recorder. We can handle the events. So here's an event listener for stop. where I'm setting this Boolean, stopped is true, and then I have the data available event. And this happens when we have a buffer. So here's the magic sauce right here. I'm creating a new window file reader. And then on load end, I'm handling this function. After I load, I convert the reader result into a base 64 string. And then I send the buffer up to the AVN audio component with the data available. And if we've stopped, remember that Boolean stopped up here, then I call recording stopped. Now that all happens after we load, which happens right here, reader.read as array buffer, data. That is all the event handling. Next, I set the global variable AVN audio recorder to recorder, my recorder object, and I start it with a time slice. If you don't have a time slice, then you have to poll for data. But if you have a time slice, if you give it a number of milliseconds, it's going to fire that data available event automatically when that time slice has occurred. And then I call recording started. All right, now stopped is pretty easy. If I don't have a recorder, I'm out of here. I don't know why, but somebody called stop recording when we weren't recording. Then I call stop, set the data available to null, and the audio recorder to null. Okay, now let's look at how we wrap this thing, AVN audio interop. So it provides access to those JavaScript functions in that AVN audio JS. And with this class, the consumer doesn't need to specify a path to the JS file. The AVN audio component uses it to access JavaScript functions. So here's the magic right here. I have a module task, which is a IJS object reference, but it's a task of it, and it's a lazy task of it. In the constructor, I'm requiring a JavaScript runtime to be passed in, and I use that to get my object reference, but as a task. And the reason for that is I don't want to load everything up now. I want to be able to load this module on demand, but I still need that task, and I'll have to dispose of it later. All right, so here's enumerate audio devices. And we're passing in that .NET object just as an object. And all I do to get the module is await module task value. And then I can call it just like I would any runtime, except that it's scoped to my JavaScript file. And I call enumerate audio devices, passing in that .NET reference. So here's start recording. Pass in the .NET reference, the device ID, sample rate channels, and the time slice. Get the module, pass it on to JavaScript. Stop recording, easy. No parameters, just stop recording. And then dispose, I see if the value has been created. I get the module and I dispose of it. Now let's look at the component itself. The Razor file has no UI. So let's look at the code behind. So I'm injecting the AVN audio interop so I can access JavaScript. Now I have a callback for audio status changed. I have a callback for recording started, recording stopped. Here's my input devices, right? List of browser media device. Output devices too. I have yet to do any output, but I'm still bringing back the list of devices if you want. Here's the buffer recorded event callback, passing an audio buffer. Here's the number of samples per second, the sample rate. I default to 16,000, but you can, of course, change it. Channels, time slice, default to 500 milliseconds, half a second. Recording. Now, here's my object reference. I'm going to get this once, but I need to pass it a couple of times. Where do I get it? Well, down in onInitialized, of course. Grab it right there. So here's my start recording public method, and I'm awaiting start recording on AVN audio interop, passing in the object reference, the device ID, sample rate, channels, and time slice. Set recording to true. Stop recording, same deal. I call my AVN audio interop, which does the dirty work. Status changed is called by JavaScript when the status is changed. That's why we have the JS invocable attribute That tells JavaScript, hey, you can call this. And I raise my audio status changed event when that happens. Here's recording started, recording stopped. Now here's data available. So this passes the base 64 encoded byte array. And I have a little note here. Data is recorded as WebM, a web standard based on Opus or Vorbis. Output data sample rate is 44.8, even though the sample rate is specified otherwise. You can use FFmpeg to convert a WebM file to a CD quality WAV file with this FFmpeg command right there. So the first thing we're going to do is convert it to a byte array. And then I'm going to create a new audio buffer, setting the buffer string and the data, the byte array. And I'm going to raise my buffer recorded event. Now here's the available audio devices, which passes in an array of devices, right? So the user has said, enumerate the devices. JavaScript says, okay, here they are. It's JS invocable. So I've got a couple local lists of browser media device. I loop through them. Device toString returns the JSON for that device. And then I deserialize that into a variable device. That would be a browser media device. And kind is the property that tells me if it's audio input or audio output. There's also video input. There's other kinds. So it's an input device. Now, sometimes we get blank labels and IDs. So I'm just checking to see if they are not empty strings. And if they're not, I add them to my input devices and output devices, respectively. Now, I'm clearing the lists, the input devices and output devices lists the consumer has passed in as parameters. And I'm using add range to fill them up again. And then I call audio status changed, audio devices found. So when somebody says enumerate devices, I pass that on to AVN audio interop. Now, here's a little helper method that I wrote to write a wave header to an open stream. So the stream has to be open. It has to be a WAV file. We make sure we're at the beginning and we write the header, the wave header, based on the sample data, bit depth, and all that stuff. We're not going to use it in this demo, but I put it there for your enjoyment. All right, coming up, streaming to SignalR. All right, so I've set my AVN Audio SignalR Demo.Server project to the startup project. This is a hosted WebAssembly app. So in the program of server, I'm adding SignalR right there so I can use the hubs. Adding response compression reduces the SignalR payload size. And now this is the first time you've seen this, Audio Converter. This is a service I wrote that converts audio buffers from WebM to PCM on a background thread and writes them to a PCM file. It also does the one-off conversion. So this is what uses FFmpeg. I'll get to that next. Now I'm going to tell the app to use response compression. And then down here, I have to map our SignalR hub, process audio hub. So before I show you the hub, let's look at this guy, Audio Converter. So this has a background thread that converts the WebM audio data to PCM audio data, writes them to a specified PCM file. And as I said, it also has a method for just doing a one-off conversion of a buffer. So I have a concurrent queue. This is a thread-safe queue for storing WebM audio buffers. Now it's private. I'm not going to expose the queue because I don't want anybody messing with it. But I am going to add methods for clearing and adding to it. Working is whether or not the background process is running. And a done is a flag that's set when the background process is done. You'll see how I use those in a minute. Now for conversion, I have the sample rate, the channels. I have this flag, first buffer, used to modify data with the WebM header. I know you don't know what I'm talking about right there, but it'll become clear in a minute. Here's the file name, the PCM file name we're going to write to. And then web header, which is a byte array. So all will be explained when I talk about add buffer, which is coming up right after clear Q, which sets first buffer to true and clears input buffers. All right, add buffer. So this is where I think I've done something unique and a little bit special. I scoured the internet trying to find examples of converting a WebM buffer that doesn't have a header to PCM or anything else using FFmpeg. Here's the deal. FFmpeg is used to WebM files. If you get a file, it'll convert the whole thing. But if you're giving it buffers, well, the first buffer has a header. The header has all the audio data like sample rate and channels and all that stuff, right? And that's how FFmpeg understands how to interpret that data. But all the subsequent buffers don't have the header. So I did some reverse engineering. And after many conversations with ChatGPT, which just went, I don't know. And it guessed, but it didn't really have any good information for me. I figured what I have to do is figure out how much of that first buffer is the header. And then if it's the first buffer, I want to copy it off. 162 bytes is the magic number. I didn't find this in any documentation. I did it by experimentation. And here's the thing. I'm not even sure this is going to work for you. It works for me on my machine. I don't know if it's going to work everywhere. And if it doesn't, this would be the number to hack. So if the first 162 bytes of the first buffer are the WebM header, that must be prepended to every buffer in order for FFmpeg to convert it properly. We need to copy that. And that's what web header is. It's a byte array. And so basically I copy the first 162 bytes into a memory stream and pull them out into that byte array web header. That's only if it's the first buffer. On subsequent buffers, we need to add it. We need to prepend it to the buffer. So I create a memory stream. I write the web header. I write the buffer. And now the buffer I pull back out of that memory stream and it includes the header. Then I can add it to the queue. Then and only then, once every buffer has a header, I queue it up. Now here's a method to convert a WebM buffer to PCM. Just one buffer. You pass in the buffer, the sample rate, the channels, and now I have this new enumeration you haven't seen yet called buffer position. Buffer position is either first, middle, or last. First and last, I really care about. Middle, I don't really care about. It's somewhere in the middle. If there's 10 buffers, 0 is the first one, 1 through 8 are middle, and 9 is the last. Okay? So I'm passing that position. I save the sample rate in the channels, and I do that same thing with the 162 bytes. If it's the first buffer, I save the web header. Otherwise, I prepend the web header, and then I call my private convert to PCM, and this is what calls FFmpeg. So I'm using a system diagnostics process. Here's the file name, FFmpeg, which is going to be in the current directory. I have my arguments. These are the arguments that I'm passing to FFmpeg. This dash here means use standard input. Here's my channels, here's my sample rate, and then standard out. So shell execute has to be false. Redirect standard input and output have to be true. I start the process. I write the buffer to standard input. I flush it, and then I have to send this queue, quit. Then I close it. Now I create a byte array to read the converted PCM data into. And now I have some using statements. Here's my output stream, my memory stream. I read into the memory stream and the PCM data I pull out of the memory stream. Now I wait for FFmpeg to exit. Then I close and dispose. But that's not the cool thing. The cool thing happens when we get to the SignalR hub. I'm injecting the audio converter into the hub. I have a file name that I want to save to, output.pcm, can be whatever you want. And there's a files folder. That's where the PCM file is going to end up. So let's talk about process audio file buffer. This is what I call from Blazor when I want to write to a WebM file directly without conversion. Here's the file name. It's just the file name. It doesn't have path or anything. Here's the buffer as a base 64 string, the position, first, last, or middle, and the sample rate. First thing I do, convert the buffer to a byte array. Next, I formulate a local file name from the current directory files and file name, and I'm going to delete the file if it exists, and this is the first buffer. Right? First buffer, that file's there, blow it away. Now I open the file for writing and get the stream, seek to the end, and write the data. If this is the last buffer, then I generate a WAV file name from the existing file name, and then I call audio converter convert file, local file name, WAV file name, sample rate. Convert file creates a process to convert an entire WebASM file into a WAV file. And so the arguments are much easier and the code is much simpler. You just tell FFmpeg, here's a file, here's what I want it to write to. Boom, Bob's your uncle. All right, that's for a file. That's if I want to write to a WAV file. Process audio buffer, I can call it from the Blazor client app to process a WebM audio buffer. In other words, convert it to PCM, just one buffer. Now, if you just want to convert it and go home, you can uncomment these 3 lines. All right, we're calling audio converter convert WebM buffer to PCM. I already showed you that. Data, sample rate, channels, position. And once you have that buffer, that's PCM data. You can do whatever you want with it. You can send it on to other clients, do what you want. In fact, you could send the buffer on to other clients before you convert it. But I'm just saying, if you want to convert it and go home, there you go. But the cooler thing is to use the audio converter's background processing to convert buffers to PCM and write them to a specified file. That's the cool thing. So to do that, if this is the first buffer, I clear the queue, right? I add the buffer. If this is the first buffer, I start processing. I'm going to add the buffer no matter what, if it's first, middle, or last. I start processing, and if it's the last buffer, I stop processing. So that's all I have to do here. But let's now go into Audio Converter to see what happens when I start processing. So here's the file name. This is the PCM file I'm going to write to, the sample rate and the channels. Remember working? Well, if we're already working, we don't want to start processing again. So if we're not working, I'm saving the values I need to convert, deleting the file if it exists. I create a new thread that's going to run do work, which is the real thing here, and I'm going to start the thread. So do work. I set working to true, done to false, go into a loop. And if I have an input buffer, I'm going to dequeue it into this input buffer variable, or I'm going to try to dequeue it. And if that works, I convert it to PCM. And now this is really the code that happens next. I'm opening the file name for writing. I'm seeking to the end, and I'm writing the output buffer and flushing it, and then I'm done. But for some reason, sometimes you can get an IO exception, cannot access file because it's being used by another process. So I have this arbitrary number of 4 retries, and this does the trick for that. If one of you alert viewers wants to tell me a better way to do this, I'm all ears. There probably is a million better ways to do it, but that works. And then I sleep 100 milliseconds before looking for the next buffer, right? And I continue that while working. And once working has been set to false, I exit out of here, and then I set done to true. Then when we call stop processing, I set working to false. That signals to that loop to exit, right? It's while working. And then I wait for the done flag to be set. And then I'm done. Okay, on the client, let's look at the client. It's pretty much the same demo as I had before. I'm setting the sample rate to 44.1, time slice to 1 second. Now I have a buffer position and a hub connection. I don't have any local files on initialized. I'm going to set that hub connection. And now I've got this check connection that I'm going to call before I use the connection. I just check to see if the state is not connected and then start it if it isn't. All right, so here's where everything happens. Audio buffer recorded. I'm going to update the status, and here I'm adding the length of the buffer to bytes recorded, and I'm showing the total bytes recorded. I'm calling check connection here. And then there's two ways we can go, right? If we do this demo, process audio file buffer, that's going to write to a WebM file and then convert it to a WAV file when it's done. And I'm making sure the position is now middle. If it's first, set it to middle. When the user presses the start recording button, I initialize bytes recorded in the buffer position. I get a new file name, which I get from concatenating the year, month, day, hour, minute, second.webm. Then I call start recording on the audio recorder, enable and disable the buttons. Now, when the user clicks the stop button, I set the buffer position to last, and then I say audio recorder stop recording. There's going to be one more buffer, all right? And that's why I set it to last right here. So that will be sent because I'm passing on buffer position. So let's do that demo. I'll enumerate the devices. Here's my microphone. Start recording. Blah, 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 blah. Stop recording. Now you don't see anything, but if I close this, and now I look in the server project, in my files folder, right there is that WAV file. And if I double click that WAV file, blah, 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 blah. Okay, now let's do the second demo, which is to call process audio buffer. And in the hub, I'm going to not just convert one buffer, but I'm going to go and create a file. Right to that PCM file, one piece at a time. All right, here we go. Start recording. 1, 2, 3, 4, 5. I'll stop recording. And now you can see output PCM in my files folder. Let's pull that up in Adobe Audition. And I had to tell Adobe Audition that it's a 44.1 CD quality mono file. And here we go. 1, 2, 3, 4, 5. So this was great for testing because when I just look at a buffer, it's hard to tell if it worked or not. This works. And this is PCM data. Like, it doesn't exist on the internet. So enjoy AVN audio. I hope to find a way to play back these WebM buffers one at a time, but the method that I used to use doesn't work anymore, and things are getting deprecated and it's hard to keep up. But at some point, I will add that to this repo, so keep watching it. Now back to you in the studio, Carl. You know, with tech like WebRTC, you can stream audio and video from one client to many, just like Zoom. In fact, there's a free app called Jitsi that you can use to hold meetings 24/7. That's not the point. AVN Audio is made for getting audio from client code to server code where it can be analyzed, bent, twisted, and hammered. And that is what you get for riding the Blazer train. Hey, thanks for riding the rails with me today. This is where I jump off. I'll see you next time. Blazer train!